Welcome to General Biology. Today's presentation is going to be on non-Mendelian inheritance, and we are going to focus on X-linked traits. So X-linked traits are traits that are on the X chromosome, one of the two sex chromosomes, and they're going to be much more common in males than females. Because females have two X chromosomes, they have a backup gene, where males only have one X chromosome. And so if there's a bad gene on our X chromosome, we have no backup plan. And so these traits like hemophilia and color blindness are much more common in males than females. We're going to focus our presentation today on color blindness or red-green deficiency. On the X and Y chromosome, there are many more genes on the X than there are on the Y. And the genes on the X are important for survival. The genes on the Y are not, obviously, because no females have a Y, and if they were important for survival, all females would die, and that doesn't happen. The Y chromosome is pretty much exclusively designed to convert you into a male. So all organisms, or all humans, start off female, and then about 10 weeks into development, the Y chromosome kicks in if you have one, and it will convert you into a male. Now, how do sex-linked traits get passed on? Well, they get passed on a little differently than what we've seen before. So before we just wrote the letters in the boxes. With sex-linked traits, you have to use a little bit different diagramming system in order to show how things are passed on. So in the case of color blindness, we'll use big N to represent normal color vision and little n to represent poor color vision. And so in this case right here, we have a male that has normal color vision. And over here we have a female who's a carrier for color blindness, but she has normal color vision. When they have offspring, there's a 25% chance that they'll have a female that has two big N's. There's a 25% chance they'll have a male with a big N. There's a 25% chance they'll have a female that's a carrier. And there's a 25% chance that they will have a male that is colorblind. So what does colorblind mean? Well, it's not truly colorblind. We call it red-green deficiency. And what happens is the red, you can see red and green kind of look like the same color. And so people who are red-green deficient have a really hard time seeing red, this color, and distinguishing between the two. Purple to them looks kind of just like a gray or blue. So they don't see the red and purple. It just looks like a gray or blue. But green and red almost look identical. So the way these things are passed on is the normal color vision comes from mothers to sons. Dads cannot pass on the trait to his sons because he's going to pass on a Y to his sons. And so when we are doing the inheritance of sex-linked traits, dads are going to pass an X to their daughters and a Y to their sons. So the trait that a son gets comes directly from mom. So if she passes him a normal color vision X, he'll have normal vision. If she passes him a defective X, he'll be colorblind. If you are colorblind, you would not be able to read the word color here. Okay, so all of these dots would look the same color. If you were colorblind, you would not be able to see the 42 that's in this picture. And if you were colorblind, for most of you in class, this is going to look like a green team playing a red team, and the red team has a little bit of blue in their socks. If we were all colorblind, we would see it like this. So it's a little bit of different situation. The reds and the greens look identical, kind of like a muddy, I don't know what you want to call it. And the blue still looks blue to everybody, but the greens and the reds have lost their color.